Hi everyone and welcome back to the series about the Swiss bracket. In this video I am assessing the quality of different pairing strategies using simulation-based research. So if you're not aware on how simulation works, I'll do a little quick tutorial. So I have a tool, RSTT. I can generate players. I have G2 now with a level of 1600. I can make them play games. So G2 beats Fnatic 1-0. I can generate more players and put them in a ranking. So as you can see now, we have Paul, Patsy, Maria, 16 players. Okay, it starts from 0 to 15, but that's a coding convention. Um, with my ranking, I can use it to see the competition, and I can run the simulation. It instantly produces my standing here, so I can see that Paul finished first, won the tournament in a final against Patsy, who finished top two, and we have Debbie and Willie completing the top four, which are top one, top two. Debbie is fourth, fifth actually, but that's how it runs. Okay. Now I can do some fancy stuff. If I have a ranking like this one, I can re-rank it. So it gives something like this. Now Patsy, who is the second best player, is now at the bottom of the ranking. This only changed the ranking. It doesn't change the level of the involved player. It's just a way of studying how seeding affect competition. It's a very practical use case. For example, in Counter-Strike, we have a world ranking from HLTV, a world ranking from Valve, and they do not agree on Navi, the second, and for example, Falcons, the sixth. Navi third, Falcons is four. Those are not the same ranking, right? And they cannot be both correct at the same time. So with my simulation, I can study how it will impact. As you can see, we don't have the same finalist here. And Patsy lost in the first round. The reason why it lost in the first round is because it has the lowest seed, and with the lowest seed, you face the first seed, which is the best player, and sadly, he lost the game. Okay, so this is the way a simulation can be useful to assess quality of competition. Now, if I go back to my simulation, this is my simulation notebook. It's very complete. I will not cover everything, but again, you can download it, run it. Little warning, it takes a few hours. Um, and check for yourself the results. Um, what I have here, I loaded teams, basic team, Counter-Strike teams, and I rerun the example. So I created the original example from the tweets. As you can see, we have Ants in the final round beating G2, Vitality beating X9, and Astralis qualifying thanks to a favorable encounter versus Monte, which is exactly what happened here. You can take time if you want to verify that every game are the same, but it is. So we reproduce the problems from the X thread. Now, this is the major proposition, which technically improves competition, but we'll see it doesn't in a few minutes. There is a limitation on the covering. You can read it. It's actually interesting. Now, I also implemented a system for my expected matching approach. I am using the F1 rotation, F1 rod 013. So if you remember from the second video, it's this system here, F1 rod 01. So we are expecting a bunch of the fourth best option from Valve. Okay, I propose to test the major without tiebreaker because I said it doesn't make sense to use tiebreaking in this system. So we have six major Swiss bracket variation, which includes my system and the current major system. I also included the group stage, four groups of four teams each, and which is what is done in sport and what was in place before the current system. I also included the two group of 8 team, which is what is used in ice hockey. As I explained you, I can change seeding, so I've developed different class of seedings. They have different qualities. There is a random one, which is really just bad seedings, and then ACR2 is a type of seeding which preserves the top 8. So the ranking is not correct, but the 8 top seed are indeed the 8 best team. So they have a 100% top 8 preservation. The seeding classes, they are, except the random, they are of good qualities. If you are familiar with ranking, rank correlation, those are, you will see, you know that they are good. Okay, I'm not covering the population model, but basically those are the way the probability are computed. You can go for it, look, check the probability distribution. This is probability of qualification without bias in a round robin. And then I just run the simulation. And this is about 800,000 tournaments that are simulated, which involves something like 25 millions of game, if I remember correctly, and if I didn't mix up the numbers, which always quite an heavy data set. To help us explore the data set, I have done a dashboard, and I will start with the last round pairing system. So what it does, what we're watching here is the percentage of last round that are fair. So basically, I am checking how often these 3 games are top seed versus bottom seed. And as we can see, the original and the major, it's frequent, but it's not all the time. With the expected matching approach, it's 100% of the time. So the parameter I use is we know which are the top 8 team, and it's always the better team that wins. If I introduce a little bit of randomness, the major system quality drops significantly, but the expected matching approach remain of extremely high quality. And this is not just based on the seedings, it's actually also true from the true level of the player. They are actually the 3 best teams, not the 3 highest teams. The 3 best teams are very often facing the 3 lowest team. Okay. Here is by Valve's index priority. And as you can see again, if it's the better way and you know who are the top 8, it's very often that you have the good. But if I introduce more random class, more seedings and less quality seedings, as you can see, the pairing of the last round in the major system is completely random. And that's why you have random results here. But for the expected matching approach, it's consistently the force, which is what it's supposed to do, right? It was created to make it very often that we have the force pairing, and this is what we have. Um, so it's a confirmation that the expected matching approach does what it's supposed to do. We can introduce randomness, and you can see that it remains. Expected matching approach produces a lot of the top 6, while the major doesn't. It's completely random. If you see here, it's not always the fourth, it's sometimes the first, or very often the first. And the reason why is the expected matching approach ensure that the fourth option is available, but doesn't enforce it. It respects Valve's rules, and Valve wants the first to be played if possible. So that's why it's played when there is a randomness. But it ensures that the fourth is available, and if not 1, 2, 3, then we play the fourth. Okay. So the expected matching approach does indeed achieve what it was designed for. And now the question is, does it improve tournament quality? So to check that, I looking at who are the 8 team qualified, and I computed as a percentage of which of the top 8 best team do qualify. So if we look at the major, the previous design and the current design, and you look at deterministic result and the case where you know who are the top 8 team, your seedings are correct in that regard, we can see that it's not 100% all the time, and it should be 100%. If you know who are the top 8 team and the games are there are no upset, then you should be able to qualify the top 8. So there is indeed a little issue, and we know it from the example. And if we compare that to a group stage, we can see, yeah, group stage achieve 100%. And if you compare with 2 groups of 8, yes, it also does 100%. And the expected matching approach also does 100%. So it's not a question of the tournament design, it's the pairing system that is problematic. And the expected matching approach, by addressing the last round structure, managed to correct the behavior of the tournament. Now, I want you to look at this and the deterministic case, because it's the only situation where group stage are better than the major system. If you introduce randomness, upset, then the major system, the system does better than group stage. Group stage are, generally speaking, horrible. Yes, on paper they work when you have perfect situation, but the moment you introduce randomness, the major is superior. And once you have worse quality of seedings, it becomes even more obvious that the major outperform. And for the expected matching approach is also the best when it comes to run upsets, probabilities outcome, and different seeding classes. What can I add? I don't want to make a 20 minute long video, but there's plenty metrics. You can check fairness, you can check balance, you can check utility lots, which is utility lot is a metric that goes a little bit more in detail. It assesses not just what percentage of good team qualify, but it makes a difference if you qualified uh, if the best team is not qualified versus the worst. So if a system, let's say this way, if you qualify 1, 2, 3, 4, 5, 6, 7, then you have the same score as qualifying 2, 3, 4, 5, 6, 7, 8. But there is a big difference in qualifying team 8 and team 1, and the utility loss makes that difference very efficiently. I can add one more thing, is that I said that no tiebreaker make no sense. And if you run simulation with the current major and you remove tiebreaker, you can see the major perform better when you don't have tiebreaker. And it's the same for the original system. And you can see that was the original system. And we decided to create this, which is weaker. And we could have just have removed tiebreaking and it would have been significantly better. In fact, if you remove tiebreaker, you reach performances equivalent to the expected matching approach. Which is, okay, for my side, it's a bit disappointing because I solved what I consider a quite difficult problem. Now, I'm very happy with the result of the expected matching approach, and I believe the expected matching approach is superior than any system available in my simulation. But I want to point out, no tie breaking works very well, and it's a very weird idea to play the system with tie breaking. And it was even more weird to maintain it when there was a problem. Okay, I don't want to make it longer now. Thank you if you're still watching the video. Thank you very much for your attention, and hopefully I was able to share something with you. I was able to convince you that one, the major format, and now the League of Legends format is excellent. It is by far superior than anything that exists, at least that I know of. And on top of that, I was very happy to be able to work on such a problem and contribute with a little bit of an improvement. Thank you very much, and bye bye.